Let's take a look at linked lists. A linked list consists of a sequence of structures called nodes, where each node is linked to the node following it. Pointers are used to point to the first element of each node, and these pointers are generally the last element of the preceding node. So, as we see one right there. The first element of the first node is also pointed to by an initial pointer, which is separate from the linked list. The last element of the last node is the null pointer. Some sort of data is generally stored inside of each one of the intermediate elements of the node. So let's take a look at a specific example next. So here we define a linked list using the structure. So type def struct, and then node underscore s is kind of the temporary name of this data type. Between the brackets here and here consist of the components. So here we have a character array with 4 elements in it. So we have room for 3 characters and a null character. And then we have another component which represents the price. This is an integer. And finally we have a pointer of type node s, which is pointing to the next link in this list. So we generally always call this star linkp. And then finally node underscore t is the actual name for this data type that we'll use normally. Okay, so here's what a linked list, this particular linked list would look like. First of all, we have a pointer here which points to the beginning of the first node of this linked list. It's a pen. That's the 3-letter name. Costs $1. And at the end there's a pointer which points to the next node, which is here. This one's a toy, $9. A pointer which points to the next node, which is here. This is a car, 20,000. And finally it ends with the null pointer. Using simple functions, we can add links to the beginning here or the end of the node. We can remove links, so we could take this one out, or we can traverse the linked list and go through and read out the elements of each one of these pieces of data as we go through. These lists work particularly well with dynamically allocated memory, as we can allocate and deallocate memory as we need it to add or delete the nodes. So just a couple of things to note. If n underscore p is a pointer to the node, then n underscore p arrow name is the name stored in the node. N underscore p arrow price is the price stored there. N underscore p link p name is the name stored in the second node. And link p arrow price is the price stored in the second node. Notice we can also get to the second node by using the following set of instructions. If I define a new pointer here, n underscore p, as equal to n underscore p arrow link p, then n underscore p arrow name will get me to the same point of the second node. This little section of code here shows what we can use to traverse the list, that is to go through and look at each one of these things in line until we get to null. And this is indicative of what's in all of the programs that are written to do anything with this kind of a list. So let's take a look at this. First of all, we set temp equal to the head pointer. That's this one. So now it's pointing here. Then we say go into a while loop, and as long as temp is not equal to null, that would be the very last thing here, print underscore fun temp. So that's going to call a function called print underscore fun, which will print out these 2 pieces of information in each one of these things. And then we set the new value of temp equal to temp arrow list, which means we go here and it points to the next name, so we can go to the next element. We get done with this one, we go to the next element, and as I said before, we'll keep doing that until we hit null. So here's an example of a program which searches for a particular name. So it's a node underscore t, which means it's going to return a linked list. This is the name of the program, find underscore name. We have a couple of inputs. We have our linked list here, and then we have query pointing to the name that we're actually trying to find. So we go into a little while loop here. As long as string compare, this is going to look at the name component of the linked list, and query, as long as they're not equal, and we haven't found the null pointer, then we just replace point with point arrow list p, and that goes to the next link on our linked list. When we finally get done and jump out of this, it means that we've found the particular link that has query in it for the name, and so we just return that to the main program.